Thank you guys so much. Thanks to everybody for being here to learn a little bit about some of our new technology offerings to help monitor and improve spray processes. We are happy to present this morning in a brief half-hour webinar. What I'm going to start with is I'm going to put our company email, our team email address in the chat here, so you have a way to get a hold of us in case something strikes you as very interesting and you want to learn more and schedule a demo. And then I'm also going to link us to our website as well, SprayScan.com. More information there and an opportunity as well to schedule a demo. And then to kick us off for today, I'm going to go through a very brief company introduction about spraying systems in case anyone isn't totally sure what we do here at Spraying Systems Company. And if you have any questions, please put them in the chat, and we will have a Q&A at the end of our half hour here as well. Okay, on to a brief company introduction to help familiarize everyone with this. So we can move on to the next slide. So our core business is spray nozzles, systems, and accessories. We do this across just about any spray application and industry that you can think of. So that means things like coating, humidifying, gas conditioning, cleaning, spraying anything from water to aqueous ammonia to chocolate onto cookies, and much more than that. Differing viscosities and chemistries come into play here. Through all of this experience, we've gained an expertise into spraying all of these things, and that leads to us branching out into some state-of-the-art testing and diagnostic facilities and capabilities. Where we can help discover the best ways to spray maybe a trickier solution or finding the best products and temperatures, parameters to achieve a desired outcome and reduce waste, increase safety, what have you. Additionally, we're a global company with manufacturing facilities in 12 countries across 4 continents. Over 100 sales offices around the world. Our goal is to be close enough to our clients to act not only as salespeople or someone to help fill orders, but as spray technology experts, able to physically visit facilities, see where our products will perform optimally within a given process. As far as a company intro, that's all I'm going to say. If you have any additional questions about that, please put them in the chat. And with that out of the way, we'll move. I'm going to hand it off to Justin Berger, a very accomplished spray technology expert who specializes in reducing waste through innovative solutions, among a multitude of other things. So yeah, from there, take it away, Justin.
Thanks, Peter. I really appreciate the intro and really all of y'all's time as well. We know that your time is very valuable, and our ambition is to really share a bit of our knowledge and our experience and what we believe is a huge competitive advantage that your company can glean from some of the knowledge that we're offering here. So the main piece that we're looking at is monitoring your spray processes. And even though folks might have SOPs in place to understand the wear and understand how their nozzles are moving and performing, we also are able to lift certain insights and share certain pieces of knowledge. Like Peter had mentioned, there's different viscosities, temperatures, those kinds of things. And once you start looking under the hood, you can see that even a singular degree increase or decrease of an oil or a mold release that you're spraying has significant impact on your spray performance over time. Short story, there was a client we were working with, and in the summer months, their sprays were working great. In the winter months, it was awful. And what we had learned is that the viscosity was changing, thus their spray performance was changing, and it caused all kinds of issues downstream from their process. And a very simple thing was just controlling that temperature of the oil and alleviated the seasonal conditional changes that they're working with. And those are kind of the small nuances where we as specialists are able to come in, look at the holistic process and see where things may or may not be coming together. And we have a keen eye for that. So on the next slide, I'm going to share a little bit about kind of the 3 main distinctions of nozzles and kind of that effect of nozzle wear. So You have a solid stream, you have a flat spray pattern, and then you have a cone spray pattern. Those are the three main hydraulic types of sprays. And you can see all kinds of different things as a nozzle wears. In a solid stream, you'll see a change in spray angle. Also, you'll notice that over time, that orifice will wear out. So it'll start flowing depending on the type of pump you have, more liquid out there. And then so suddenly your PSI will start to drop. So maybe cleaning efficiency will decrease, or you'll start seeing a higher consumption of your resources, whether it be from your pump or from water consumption, all of those things, because every little aspect plays a role. On your flat spray patterns, you'll see an uneven distribution and changes in coverage. Also, we've seen some cool things in our innovation center down here is the spray will actually dance and it'll actually move around. So if you're trying to get a nice even coating as it wears, you'll get some maldistribution, which we'll share a little bit more of what that looks like here and perhaps how to mitigate it. On your cone pattern, you have a reduced pattern uniformity. This is really important for typically gas conditioning applications. Uniform distribution is important. It can also be important for various cleaning applications as well, or cooling aspects. But you'll notice that what we call the relative span factor, those droplets become a wider array of droplets. So process controls ends up being a little bit harder to predict. And with decreased predictability, operationally, things start changing. On the next slide, I'll show you a little bit about how these nozzles look, may look in the field. So you have three primary aspects that to look out for on your nozzles. You have erosion, corrosion, and adhesion. So with erosion, those are physical forces, right? The physical forces that are changing the orifice or the mechanics of that spray. And one of the things that we've learned, as soon as you start spraying any rheology through a nozzle, the performance over time will change. And you can switch out metallurgies and different things to stave that off a little bit. But as soon as that nozzle is pressurized, things do start to change. The rate of change is different based on the nozzle, the design, and all those things. But it's important to know as soon as you're operating, it's just like a car engine, right? You change the oil, but over time that engine does wear out. And it's the same aspect for your pumps, but also very similarly for your nozzles. Here you have corrosion. Corrosion is a very insidious piece inside of processes. So we've seen all kinds of aspects with corrosion. It can change the metallurgical characteristics to where it is weaker, can't handle the higher pressure drops. Also, the maldistribution from the orifice as well. It will weaken, it could embrittle the material. And then lastly, you have adhesion. You see this a lot with smaller droplets, small spray applications where you're depositing solids, and those solids accumulate perhaps at the periphery or around the surrounding areas, and it can begin to create buildup and occlude that spray pattern. And again, creating that maldistribution, which is pretty detrimental to various applications, whether it's spray dry, or even creating drift mechanisms throughout your facility. If you're spraying particle-laden flow and those droplets are really small and they start depositing and they can actually beard and build up over time. And so that's kind of the things that we notice on the macro scale. Now, on the next slide, what you're going to see is how difficult it is to actually detect nozzle wear. Oftentimes we'll go to plants and visibly inspecting a nozzle is not enough. Typically, the eye can discern about 20 to 30% wear when they have a trained eye of what a good nozzle looks like. So you think about 20 to 30% and what that means from an energy consumption, from waste, from water, from pumps, electricity, product, all of those aspects, they really add up. And that's just a singular nozzle. So on the left side, you see a new spray tip. This is just a typical V spray pattern, flat fan spray. And then on the right, you see a worn spray tip. So what's you're looking at on the right is a just a distribution of that spray. And you can see the top one has a nice even distribution throughout that profile of that spray pattern. Going down, you notice that you get a little bit steeper of a mountain, steeper hits. And so you have maldistribution whenever you're trying to coat certain products. And that maldistribution can lend itself to several issues downstream. And these are the things that really make a big difference inside of operations, inside of different plants. So this is a nice little test, and even folks who study and understand sprays, to be able to see that distinction of this specific nozzle, you can see how hard it is to see from, a new nozzle, 3%, 6%, 17.5% wear. That wear mechanism is critical, particularly as we look at all the ESG and the energy savings and usage. But really, it comes down to economics. If you're spraying more than what your original OEM equipment was spraying, it's going to cause a lot of extra cost, a lot of extra maintenance, and there's peripheral aspects that start happening when we start spraying more than what was originally intended. So here's just some examples. If a nozzle is spraying 4 gallons a minute for one whole year, a new nozzle, if it's still within that spec, there's no perceived waste. At 3% wear of that 4 gallon a minute nozzle, you're at 60,000 gallons per year. 6%, 120,000 gallons per year, 17.5, 360,000 gallons per year. So that's just spraying liquid or spraying water. Depending if you're spraying various rheologies, that expense can be exponential. And then not to mention the cost to drive that 17% overage of your spray, and then the product rework that may be happening downstream. And what we've noticed is a lot of folks operationally are not able to pinpoint where this is all causing issues. Usually it's kind of the last thing that they look at is, man, downstream, I'm getting all these issues. The molds are just causing, their striping, or maybe I'm not getting adequate coverage. We look at the nozzle, and it's a very simple aspect. The nozzle's worn out, get it back in within range and in spec, and then things start operating optimally. So on the next slide, what you're going to see is, nozzles are ubiquitous across nearly every market vertical. The screens that you all are looking at, the microchips, there's a spray nozzle involved with every aspect of that, from the plastics to the gasoline to you name it, a nozzle is there. And this is just some averages that we've noticed from our experience of how many nozzles are in a typical plant. So in a paper industry, it's about 900, bakeries, about 350. In the power generation side, it's about 500. Steel is about 3,000, and food, about 1,300 nozzles per plant. And so when we start conceptualizing the power that a nozzle has inside of these operations, there's a significant amount of opportunity on just understanding the wear aspects of a nozzle, and perhaps how we can, you can partner with us to start unlifting and seeing where there's other opportunities from an economics perspective. And then from there, I'm going to give it over to Paul to talk about more on perhaps how we can start bringing what we do in our lab, in our facilities, and that can start being a tool and an aspect for you all to leverage and utilize to get optics of your operation.
Thanks, Justin. Yeah, so today we're here to introduce our SprayScan suite of instruments, specifically the SprayScan mSM, or the sustainability monitor. But we have a host of different instruments here. This is all brand new product for spraying systems, various stages of development here. We're working on developing systems to measure the outputs of the spray. If you see the bottom two examples here, showing the sprays, an illumination of a cross section of the spray, looking at the distribution of the spray, which Justin had talked about how that would change as nozzles wear out. And the SprayScan mSM is looking at the inputs to the nozzle. So these systems are all designed to be easy to use in diagnostic instruments. You know, taking what we've been using for a long time in our lab of instrument grade instruments or lab grade instruments, and making commercial products of these that can be used to monitor spray processes with some real-time monitoring capabilities. So the SprayScan mSM here is a low-cost system to monitor the performance of nozzles and headers. Nozzles, we're looking at the inputs to the nozzle, the important characteristics, pressure, flow rate, and temperature. We all know, you know, a nozzle's job is to restrict flow, and its nozzles are specifically engineered to do other wonderful things like, you know, various drop sizes, capabilities, spray angles, spray plume shapes, and the like. But ultimately, pressure and flow are the chief objective of a nozzle. And as nozzles wear out, you know, it can, as Justin had illustrated, it can have a big impact on the amount of water chemistry that we're spraying and the other various inputs that go into generating that water and flow rate, or the pressure and flow rate to the nozzle. And temperature is very critical in some applications, not all, maybe. Justin highlighted a good example on like a release agent, how temperature changing of just a few degrees, you know, can greatly affect viscosity and change how a spray coating process can work. So the SprayScan mSM is designed to be a simple system that encompasses these three characteristics all in one system, gives data logging capabilities, and is programmed with all of our nozzles and operation parameters of our nozzles, so we can monitor for specific targeted expectations of that spray process. So here's a little demonstration of how, just going through the screens here, of how the instrument works. You plumb in the sensor module into your piping, feeding the nozzle or a header of nozzles, and you fire it up, and it just gives you simple pressure, temperature, and flow rate measurements. To get the advantage of the targeted operation monitoring, you go in here and you can program in which nozzle you're using, number of nozzles, the pressure you expect to be operating at, and it automatically will calculate the expected flow rate based on water. If you're using a different formulation, that flow rate may be a bit different, and you can override that and put in your expected targeted flow rate and then the temperature. And then you can select which of these parameters will affect the visual alarms on here, because sometimes temperature is just not critical, and doesn't matter if the water is 50 degrees C or 80 degrees C, depending on day of temperature in the factory. But this gives a nice way to monitor for that with some historical measurements here, as we saw at the end, and a flow totalizer as well, which is a nice way to keep track of your overall consumption. This pairs nicely with remote monitoring service as well. But before we get into that here, just kind of go over the highlights of the system here. There's two main components that make up the SprayScan mSM. You got the sensor module here, which has got our package of sensors in here for pressure, temperature, and flow rate, with these capabilities here for this first version of the SprayScan mSM. So we're looking at up to 5 gallons per minute of flow rate measurements and up to 150 psi. So that really covers a large range of our smaller core nozzles. And you can work with multiple nozzles on a header. It wouldn't give you the flow rate per nozzle if you have monitoring the header, but it'll give you the full header flow rate, so you can keep track of that. And that pairs with the monitor package here, which has a 5-inch touchscreen and has the sustainability monitor application built into it. And then if you're going to take advantage of that optional smart monitoring service, it has both Wi-Fi and Ethernet options here to connect to the internet for that service. Here's a bulletin with some more information. This is available on our website, sprayscan.com, that Peter has already referenced, and this has just all the details here about the power requirements and capabilities and some more information. The smart monitoring service here is a nice unique feature of this system. This really gives you a nice way to data log and track over time the operation of a SprayScan system of the mSM, monitoring that process. You have a product that gets rejected for whatever reason, or something happens where your release agent isn't doing its job, and product is starting to stick to the molds. You can look back at when some parameters change for that spray process, like pressure or flow rate or temperature, and have an idea of how long you may have had bad product or how long it took for that process to be impacted by that by those events. And the surface here, and going to go to the live version here, really has a lot of flexibility. If your plant has multiple SprayScan MSMs, or if you want to monitor them from multiple plants, all from one location, or it's a nice web-based platform here. You can get a drop-down list of all the available units that you have, and you can look at real-time or historical information. You could do a data aggregation, you could do averaging, or look at mins and maxes. And it's really flexible. You can go back and look at historical measurements from a specific time. You can zoom in on the data very easily. You can export the data from each widget in CSV or Excel formats. And then we have a detailed page here that's got all the information all built into one widget here that you can export and have it all in one place. And then flow totals as well. So really, really easy to work with, and gives you a lot of capability in a nice, small, simple package.
Yeah, Paul, and you know, the real value here is as we collect more information qualitatively. Historically, we've been able to look at it, say, oh, that spray might be a little bit off, but now we can quantify that. And really, a lot of y'all in your plants, you might have Allen Bradleys and all these other aspects already. This is meant to be a tool for y'all to get very quick and easy data off of that nozzle performance, or if you want to start to do in-house testing, right? Let's say you have an array of a few hundred nozzles. It just doesn't make economic sense to plug this in. You could put this offline somewhere to where you actually test it, and you can just get a flow, pressure, temperature reading on how that nozzle is performing. And that will start informing replacement cycles. These nozzles are so inexpensive versus the cost of energy usage and all of those aspects. Parameterizing and getting data around that, we believe is a huge benefit to the operational aspect of many folks who do utilize our nozzles. It's just creating that awareness. So Paul, I really appreciate you sharing a lot of this information. And there's several other pieces as well that, you know, we had the SprayScan MSM, and also the ability to visualize a spray as well, which we didn't touch on too much. But really, what we'd love to do is, if there's other aspects that we can help you out with, feel free to schedule a visit. You can reach out to Ron or myself, as we manage most of the folks who are on this call, and we're happy to help out to see how we can help out your process. Peter, I did see there were a few questions on the chat. Maybe we can pull one of those up.
Yeah. So we have a couple questions here. The first one, actually, both are directed kind of at your section here, Justin. And the first one is, for solid spray, how do changes in spray angle affect impact pressure? And the second part of that is, does impact only relate to spray angle, or how about mass flow rate as well?
Yeah, all of those things. That's a great question, Amir. All of those play into account. What we see with solid stream nozzles, they typically don't wear too terribly. However, if there is an abrasive, what we notice is that orifice size will start to wallow out. And of course, impact is a function of area, right? Cross-sectional area. So as that area increases, your impact measurements will change. But that's a spectacular question. And then you were asking, what is the optimal distance from the nozzle tip to measure spray distribution? That is a great question. And actually, Paul, you would probably be better suited for that. There's all kinds
Yeah.
of goals, and you need time for that spray to open up and to actually have that primary breakup occur. So Paul, maybe you can speak a little bit to that.
Yeah, so in our lab, we like to measure spray distribution at the distance that's, basically the application distance of what our customer is using in their process. So if you have a spray coating process and your nozzle header is normally, 6 inches or 8 inches above the substrate that you're spraying onto, that's where we like to do the distribution measurements. Yeah, it's good to have a fully atomized spray and to be, somewhere in the realm of where the data makes sense for what that nozzle and that spray is doing in the process.
And Paul, you and I have done so many projects together. That spray distance will change, like you mentioned, based on the area of concern for the client. If the substrate's only 3 inches away and they have that amount of time, well, then that's where we're going to measure it. If it goes all the way down, let's say it's 12 inches, well, then that's where we're going to try to measure to replicate what's happening in that process.
Yeah.
So I think the short answer is there's no the optimal portion is what's optimal to your, to where we get the best data and also the best performance for what you're looking to achieve.
Yeah, and air
Um,
entrainments do have an effect on spray pattern, especially when the droplets are really small. So under 50 micron droplets are very easily entrained in the air, and even a little bit bigger ones. So that can play an effect. So that happen. You get that a lot with high pressure, kind of fine mist nozzles, and with two fluid nozzles, which we call air atomizing nozzles.
Yep. And Chuck, I see your question, does a SprayScan monitor air atomizing nozzles? So what we looked at today was the fluid side of things. So it will measure fluid flow rate. Also, on the other aspect of the SprayScan, we can actually measure the actual spray performance itself optically with a laser. We didn't discuss that too terribly much, but we can send you a bulletin on that to where we can actually glean how that pattern is progressing over an area of concern. So yes, we can absolutely monitor that as long as we're within those flow parameters that we have. We can let you know how that area is going. And two, on your two fluid nozzles, it depends as well, and is very helpful if you have an internal mix, external mix, all those aspects, which again we can discuss. Have another question here. Good question. Can we use this system with all nozzles and spray applications, domestic sprays like kitchen cleaner or air fresheners? And final question, can we monitor spray on multi-phase flows like spraying water with, Amir, you and I need to talk more on spraying nanoparticles and those things. Very, very interesting question. But the MSM can absolutely, as long as there's a flow and a pressure regime, we can measure that as long as it's within those boundaries. And again, the SprayScan MPT, we can utilize that. You're not going to actually measure the individual drop size, but we can get distribution, and we can talk more offline about
Yep.
some of your interests there.
I'll take the next question from David. Confirm that the connections are 3/8 inch MPT female. Yeah, the standard is 3/8 MPT female. We also have BSPP and BSPT, the same 3/8 inch size, and sanitary flange. So we have those different options available. The picture showed push tube fittings. That was an adapter that was threaded into the 3/8 MPT fitting just for quick connection of the plastic tubing was used in that demonstration. And to expand a little bit more on the atomizing air or air atomizing nozzles, Justin talked about the liquid aspect of it. We're also we're also working on developing a sensor package designed for the compressed air monitoring as well, pressure and temperature and flow rate.
Yep.
So that'll be something that we'll be looking to come out with in the near future as we look to expand on this SprayScan sustainability monitor product.
Yeah, and as we're coming up at 10:30 on the nose, we're happy to stay on, but we do want to be respectful of anybody's time who needs to go. Just kind of leave you with these parting thoughts. Don't hesitate to reach out to Ron, myself, or the SprayScan team if there's anything that we can help out with. We do have the expertise and the specialists available to execute and to help guide whatever applications you're looking for. And the other piece is that this technology is really we're working to develop this technology in parallel with our customers, meaning we would like to get this into the field, operate together, get collaboration. The main thing is to democratize the data, get it in your hands, and then from there we can work together to really make a big impact on the spray performance that you guys are working for. With that, I see, yeah, we'll reach out individually to some of the folks on the chat. We'd love to talk more. And if there's anything else, don't hesitate to reach out. We're happy to be a part of your team.